Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your next module, that is the procedural programming module. In the last class we have discussed C instructions, what are the C instructions and what are the decision control structure. We also started the chapter number 2, that is the decision control structure. In that we have discussed if-else condition. Now I'm going to continue with your if-else condition, that is the nested if and the if and the if-else, that is how different ifs are used within the if. So that is today's agenda, today's topic. But before this, as usual, let's talk a quick review, or let's take a quick review about the things that is C instructions. Right. So let's start with the last session. This is C instruction, that is any instruction, means any data that is written within the C is known as the C instruction. That is group of English statement is known as instruction, and there are multiple instructions that is available in the C. C provides three types of instruction. One is type declaration, one is arithmetic, one is control instruction. So three instructions are available. In type declaration instruction, it is used to declare the type of a variable used in a C program. That is, it is used to declare the type of the variable, that is the data type. Either it may be int, either it may be float, either it may be double. So it is used to declare the type of variable that is used in the C program. Then next is your arithmetic instruction. That is arithmetic instructions are also available in the C. For example, plus, that is addition, subtraction, division, multiplication. As well as there are some control instructions also, that is used to control the sequence of execution of various statements. That is, we can execute multiple statements, we can control the sequence of or execution of a statement. Since the elementary C program would usually contain only the type declaration and the arithmetic expression, we will discuss only two instructions at this initial stage. That is, only two instructions are declared in the yesterday's class, that is type declaration and the arithmetic instruction. So these are the two instructions that we will discuss in the last class. What are these two instructions? What are the instructions? That is type declaration and the arithmetic instruction. Now, type declaration instruction, that is instruction that is used to declare the type of the variable. As I told you, it is used to declare the type of the variable. What is the type of the data? It may be int, it may be float, it may be double, it may be long. So there are multiple types that defines how many types are available for the data. That is a type declaration instruction. There are several subtle variation of the type declaration instruction that are discussed below. This says, while declaring the type of variable, we can also initialize it as shown below. That is, int I equals to 10, 25, float a equals to this one. That is, we can declare the type, that is the int, that is the float. So these are the types. This is also a type. The order in which we define the variable is sometimes important note. So we have discussed multiple features, multiple scenarios in which we can discuss the type declaration instruction. The following statement would work. This is the statement that is work. That is, first of all, declare the variable of type int, that is a, b, c, d. All the variables are of the type int, that is, it takes only integer value. Then we are initializing the value with the 10, that is a equals to 10, b equals to 10, c equals to 10. But if I declare, that is, int a equals to b equals to c is equal to 10, no, it's not possible, because at the same time you are declaring, at the same time you are assigning the same values to the b, same values to the c, same values to the d. Then we will discuss about the arithmetic instructions, that is, what is arithmetic instructions and how we can use, or how arithmetic instructions is used in the C language. That is arithmetic instruction, and that contains addition, subtraction, multiplication and the division. This is an example. In this there are arithmetic operators. These are the arithmetic operators. This is the assignment operator. 2 and 5 are the integers. 3.2, that is the decimal points, are the real constants, and AD is the integer variable. And KOT, delta, alpha are the real variables. This says C arithmetic statement could be of following three types. That is, it is of following three types, that is either integer mode arithmetic statement that contains only the integers value, or real mode arithmetic statement that contains only the decimal values. One is the mixed, that is a combination of the integer and the real. Therefore, though arithmetic instruction looks simple to use, one often commit mistakes in writing them. C allows only one variable on the left hand side of this one. That is, if we are using the assignment operator, that only one variable is used before or on the left of the assignment, that is z equals to k into I. But if I write, or I will write k into I equals to z, that is not legal. In the same way, we have discussed multiple points, that is ASCII value is used for the character sets, that is z, that is American Standard Code for Information Interchange. Then we also discussed about the arithmetic operation that can be performed on the integer, on the floats, and on the chars. That is next point, or these are the multiple points that we have discussed. Then we have discussed about the this one example. First of all, header file is included, that is math.h. There is a main function, there is a variable declared, that is a. In this we have used par function, because par function is stored in the math library, that's why we use the header file, that is math.h. This says par function is a standard library function. It is used to raise 3 to the power of 2, that is 2 power 3. Math.h is a preprocessed directive. It is used to it is used here to ensure that the par function works correctly. Then we have discussed about the integer and the float conversions. That is how integer and the float conversions are taken place. That is how integer is converted into float, and how float is converted into integers. These are the various expressions. That is, if two integers are converted or divided by each other, then the result is also integer. If one real, one integer, then the result is float, that is the real number. Then we have discussed about the type conversions in assignment operator. That is, when we assign, what are the type conversions? Then we have discussed about the arithmetic instruction. These are the examples. Then this is the most important part that we have discussed, that is the hierarchy of the operation. That is, what is hierarchy, what operation should be performed first, and if the operators are of the same priority, then which operation should be come first. That is, either go left to right or right to left. This is the hierarchy. There is a first priority, there is a operators like multiplication, division, modular operator. These are the three operators, or these are the three operations that will be operate. That is the first priority, that is multiplication, division, and the modular. Then second priority is the addition and the subtraction, and the third priority is assignment. So first of all, multiplication, division, modulus, then addition, subtraction, then assignment. If they are of the same category, then use from the left to the right. These are the examples that we have discussed. Then we have discussed about the associativity of the operators. These are the associativity, that is we are going, or we are carrying from left to the right. That is, we are using from left to the right portion. Then we will discuss about the operator, that is operator. This is the example that is used for the operation part. Then we will discuss about the control instructions in C. That is, what is the control instructions and what are the types of control instruction. So in simple terms, control instruction determines the flow of control in a program. That is, it determines how control will be flowed in a program. That is the flow of control. There are 4 types of control instruction that is used in C. What are these 4 types? One is your sequence control instruction, one is your decision control instruction, one is your loop control instruction, one is your case control instructions. In first one, whenever we use the sequence, we maintain the sequence or we use the sequence that is line by line. In decision control structure, we depend on the C program depends on the decision. That means it depends on the condition, whether if this is happened, then print the output. Then loop control statement. So whenever there is a requirement to loop, that is use repetitive task so many times, that is same task to be repetitive so many times, that can be done by the loop control instruction. Then case control instruction, that is used for the switch case, that is used by the switch case. Then we will discuss a few questions, multiple choice questions. Then we have come forward to the next chapter, that is the chapter number 2, that is decision control structure. In this we have discussed about the if-else loop, what is a decision, how decision will be used, and what are the instruction that is used in the decision control instruction. So 3 conditions will be used. One is if, one is if-else, one is the switch. We have discussed only one if. Also if-else also we have discussed, but not the nested if-else. So we have discussed about the if statement. What is the if statement? Whenever we check any condition, whenever we use any condition, that is C uses the keyword if to implement the decision control instruction. The general form is that if condition is true, that is if the condition is true, then only executes the statement, otherwise does not execute the statement. This is the condition that we have checked in the last class, that we have discussed in the last class. This is the examples if x equals to y. This is the double equals to that is used whenever if x is equals to the y. Next, x is not equals to the y. Next, s is less than y, x is greater than y. X is less than or equals to y, x is greater than or equals to y. So these are the multiple conditions that we can use in the if condition. Then next point says the relational operator should be familiar to you except the equality operator. And the inequality operator, we are using the assignment operator. Then we use the main function int num. We use the printf, that is used for printing the output, that is enter a number that is less than the 10. Then scan the number, that is store the number in the memory location, that is %num. Then check the condition. If num is less than equals to 10, that is if the num, that is the num variable is, or the num variable that stores the output is less than or equals to 10, then only print the output, that is what's an obedient servant. That is if it is 0, 1, 2 till 10, then only the output will be displayed, otherwise there is no output. This is the flow chart that shows how decision will be maintained. That is first of all print enter a number that is less than 10, input the number. If it is greater than, or this is the wrong, if it is less than 10, then only print what's an obedient person, obedient servant you are. This is the next example that shows that discount is given on the basis of the quantity. If the quantity is greater than 1000, then only discount equals to 10. Then check the errors. This is first of all 2 variables will be used, that is Q2I and the rate. That is 2 variables are defined and these are stored in the memory. Now if quantity is greater than 5000, then only discount equals to 10. Then print the total expenses or the total and print the total value. Then we have also discussed about the real thing, that is how if will be used, that is how if condition will be used. That is first of all if will be used, that is condition and the statement. So first of all condition will be checked. On the basis of condition, the statement will be executed. Instead of the condition we can also use the expression, that is if expression then statement. This is the example. If 3 plus 2 modulus 5, then printf this works, otherwise not print any values. Then we have discussed about the multiple statement within a if, that is how to use multiple statement within a if, that is if within a if. This is multiple statement within a if, that is two statements are used. This is the example that shows if the year of service is greater than 3, that is if the employee is working for more than 3 years or prior to the more than 3 years, then only bonus is given as a 2500. So this is a scenario that is used. This is year of service. So first of all take two variables, that is CY and the year of joining. Then use this year of service, that is equals to the CY, that is the current year minus year of joining. Then if the year of service is greater than 3, calculate the year of service. If it is greater than 3, then only bonus equals to 2500, then prints the bonus. This is a flowchart that shows how year of service can be used, that is used to calculate the year of service, that is current year minus year of joining. Then check the condition. This is the condition. If it is yes, then bonus equals to 2500, print the bonus, otherwise no, then stop the values. Then we have discussed, no, this is what I'm going to start in the today's class, that is the if-else condition. So now, till now we have discussed in the last class. Let's start with the new concept, that is the if-else condition. In the same way what we have used the if condition, in the same way there is a if-else condition. That is, if the condition is true, then one statement will execute, otherwise the next statement will execute. That is, there are two scenarios. Till now we have discussed only one scenario, that if the condition is true, then only the output is come, otherwise the output will not come. But next is the scenario, if the condition is true, then one statement will be executed, otherwise next statement will be executed. This says the if statement by itself will execute a single statement or a group of statements when the expression following if evaluates to true. It does nothing when the expression evaluates to false. As I told you, can we execute one group of instruction if the expression evaluates to true, and another group of statement, that is a set of statements, if the expression evaluates to false. That is, we are using the condition for both, or we are using the statement for both when the condition is true and when the condition is false. Till now we have discussed only one scenario in which we have given the set of statements only when the condition is true. So that is what's the purpose of the else statement that is used, that is the if-else condition or the if-else condition statement. In a company, an employee is paid as under. So this is the scenario. If his basic salary is less than 1500, that is if the basic salary of the employee is less than 1500, then give the HRA equals to 10% of the basic salary. That is, give the HRA, that is a human resource allowance, that is given as the 10% of the basic salary. That is the next that is the condition, that is if the basic salary is greater than less than 1500, that give the HRA as a 10% of the basic salary, DA as a 90% of basic salary. If his salary is either equal or about 1500, so one is 1500 or less than, one is less than 1500, not 14 till 1499, that is 1499, then give the HRA as a 10%. Otherwise, if it is above or equals to 1500, then give the HRA as a 500 and DA as a 98% of the basic salary. If the employee salary is input to the keyboard, that is, use the scanner for inputting the value, that is, take the values from the user and store in the memory by the concept of scanner. Then write a program to find its gross salary. Now, this is a program to find the gross salary. So let's start. First of all, this is an example for calculation of the gross salary. There is a main condition, that is a main function. Uses 4 variables as a float function, as a float type. Why they are using the float only? Because that is contains also the real number, because HRA given in terms of percentage, that is 10%, 20%. So these are the 4 variables that is used, that is BS, GS, DA, HRA. BS means basic salary, GS means gross salary, DA means DNS allowance, HRA means human resource allowance. Then uses the printf, that is enter the basic salary, that is enter the basic salary of the customer. That is this is the basic salary that is entered by the user, that is basic salary ampersand BS. So uses the variable that is BS and uses the printf and the scanf for displaying with the help of printf, and for scanning, that is storing the data in the memory. Then uses the if condition. What are the conditions? If the basic salary is less than, not less than equals to, only less than 1500, that is still 1499, then use the HRA as the BS into 10 divided by 100, because the HRA is 10% of the basic salary. So HRA is 10%, 10% means 10 divided by 100 of the basic salary, that is multiplied by BS. And the DA equals to 90% of the basic salary. So this is 90% of the basic salary. Else means if it is not less than 1500, then it is obvious either it is equals to or greater than 1500. So this is the second condition that comes with the help of the else. This means either that condition is true, otherwise, that is if else, that is the else, next condition will true. So this is the scenario. Else HRA equals to 500 and DA equals to 98% of basic salary. So this is the scenario, this is the example how the calculation of gross salary will be used depending on the if else condition. Then uses the gross salary, that we calculate the gross salary, that is basic salary plus HRA plus DA. That is HRA DA plus basic salary, and then print the gross salary. That is uses the condition if the basic salary is less than 500, then use the HRA as a 10% of the basic, DA as a 90%. Otherwise, if it is equals to 1500 or greater than 1500, then uses the gross salary as a HRA as a 500, gross salary as a same, DA as a 98% of the basic salary. Then prints the value of the GS, that is the gross salary. This is the example, this is the flow chart. First of all start, then input the basic salary. Only one input is required, that is a basic salary. Then checks the condition. If the basic salary is less than 1500, that is if it is less than 1500, then there are 2 scenarios. If it is less than 1500, if yes, then basic salary is 10% of the HRA is 10% of the basic salary. That is HRA is this one, basic salary into 10 divided by 100, and the DA equals to basic salary, that is DNS allowance equals to basic salary into 90%, that is a 90 divided by 100 into basic salary. Otherwise, if it is equals to or greater than 1500, then HRA is the 500 and the DA is basic salary into 98%. This is the 98% of the basic salary, that is the DA. So there are 2 conditions. If it is basic salary is less than 1500, the condition is true, then the HRA is different and the DA is different. So this is the scenario that that is discussed or that will be solved, executed with the help of the C statement, that is a decision control statement, that is a if else condition. That is if the condition is true, then one statement will execute, otherwise, that is the else part, next statement will execute. And at last both the output are comes to perform the or to calculate the gross salary, that is basic salary, HRA, DA. So these are the 3 scenarios, these are the 3 input that is available to calculate the gross salary, that is basic salary, HRA and the DA. At last print the gross salary. So you see, start and stop are denoted by the oval. Input box is and the output box is denoted by the parallelogram. This is input, this is output, and the decision, that is the condition, is checked within the decision box, that is the is BS is less than 1500. This is the decision. Then the calculation or the process, that is calculating the gross salary, is denoted by the rectangle. This is the rectangle, that is gross salary equals to basic plus HRA plus DA. So this is the condition that is used. Then print the gross salary as well as the and then at last stop the value. Now nested if else, that is how nested if else will be used. That is within the if else there is a nested if else. First of all, let's see the point that is discussed. The group of statements after the if, up to and not including if is known as if block. Similarly, the statement after the else comes under the else block. So one is if block, one is else block. Notice that the else is written exactly below the if. That is, once the if is written, then exactly below the else is also written. The statement in the if block and those in the else block have been indented. Indented means give the right margin, that is indented to the right. This formatting conversion is followed throughout the book to enable you to understand the working of program better. That is, there is a proper indentation in the C. That is, there is a right margin, there is a left margin, so that you can read out the program very efficiently. So it increases the readability, user friendliness of the program. Next point says, had there been only one statement to be executed in the if block and only one statement is executed in the else block, we could have dropped the pair of braces. Last point says, as with the if condition, the default scope of else is also the statement immediately after the else statement. To override this default scope, a pair of braces will be used. That is, use the pair braces to avoid the conflict among the statements. Next is your nested if else. That is, uses the if else within the if else. This says it is perfectly alright if we write an entire if else construct. That is, if we write entire if else construct within either the body of the if statement or the body of the else statement. This is called nested of the or nesting of if. That is the next part. That is, if we use the entire if else statement or only the if condition within the if, that is nesting of if. This is shown in the following program. That is a quick demo of the nested if else. Main function is used, then int I, that is uses the variable, that is the int I. Then printf, that is uses the printf. Enter the either 1 or 2, that is enter either 1 or 2 number. Then scan, that is scan the value, that is percentage I, that is uses the percentage I. Then check the condition. If I, that is if I equals to 1, printf, that is if I equals to 1. This is the equality operator that is used for the comparison. That is the value that is entered by the user. If it is 1, then you can you would go to the heaven. Else, if the I equals to 2, that is if the I is equals to the 2, that is also a comparison operator. That is, if the I value is equals to 2, then printf hello was or hell was created with you in mind. That is a nested if else. That is, we use the if condition within the else. This is the if, this is the else. We use the if under the else part. Then printf hello or hell was created with you in mind. Else printf how about mother earth. That is, this is a different output different outcome that is available for the printf. So this is a example that shows how different printf or how one nested if will be used within the else, that is one if will be used within the else. So now let's see, this is the curly brace that is open, this is the curly brace that is closed. So these are the curly braces, one is open, one is closed. For this there is one curly brace, there is one curly brace. Note that the second if else construct is nested in the first else statement. So this is construct if else within the first else statement. Construct means fit into the first if else statement. If the condition in the first if else is false, then the condition in the second if is checked. If it is false as well, then go to the else part. So if the condition is true, well and good, print this output. Otherwise, check the condition. If it is true, then print the output. Otherwise, print this output. You can see in the program how each time if else construct is nested within the if else construct. It is also important to indent. Indent means giving the right margin, proper right margin to add the clarity to the program. In the above program, if else occur within the else program of the if. Similarly, in other programs, if else may occur within the if. That is, we can put the if else within the if, we can put the else within the if, that is nested if else condition. Now, what are the forms of if? That is, what are the different forms that is available for if? So these are the multiple forms that is available for if. That is how we can use the if statement. So first of all, there is a if condition. That is, if the condition is true, then do this. That is, perform the statement. That is, do the operation. Then next, if the condition is this, then do this and do this. That is the next condition. This is the using the single statement, uses the single if. In this, there is a single if uses multiple statement. That is, either do this or do this. Then next is there is a if else condition. That is, if the condition is true, then print this output, that is do this, otherwise, that is else, do this. Next, if the condition is true, do this, else do this. So there are multiple instructions in the if, there are multiple instructions in the else. Now next, if the condition is true, do this, else there is again if else in the else. If the condition is true, well and good, perform this operation. Otherwise, that is else, check the condition. If the condition is again true, then do this, otherwise do this and this. There are curly braces, this is open, this is closed, this is open, this is closed. Next, if the condition is true, then again check the condition. Again check condition and then performs the operation. Otherwise, perform another operation. This is the if else, one if else. And next is your next if else. That is, if the condition is true, then only jump to this part, otherwise jump to only this part. So these are the multiple if scenarios that will be used in the if else statement. Now next is use of the logical operators. That is how logical operator will be used. Next is use of the logical operator. That is how logical operator will be used in the C programming. That is usage of the logical operators. This says C allows usage of 3 logical operators. What are the 3 logical operators that will be used? That is either this one, AND, OR and the NOT. So these are the 3 logical operators that can be used. One is AND, one is OR and one is NOT. This can be read out as an AND, AND, OR and the NOT. There are several things to note about these logical operators. Most obvious, 2 of them are composed as a double symbols. That is, this is a double, this is the double. Don't use the single symbol, that is this and this one. This symbol have a different meaning. That is, if I think that only single is used, that is this is by mistake and double are used. No, that does not make sense. Why? Because the single operator have a different meaning. These are the relational operator, not the logical operator, and the double symbols are the logical operators. That is the use of the logical operator in C language. Then next point says these they are bitwise operator, not relational operator. Single operators are bitwise operator. That will be discussed in chapter number 14. The first two operator, that is this one and this one, allows two or more conditions to be combined in an if statement. That is, these two conditions are used to combine two statements. That is, if this is the AND, this is the OR. That is, two conditions are checked. If the both the condition is true, then the AND operator will be used. If either one of the condition will be true, then only OR will be used. So we can use for the two statement, that is using the AND the OR, that allows two or more condition to be combined in an if statement. Now let us see how they are used, that is how logical operators are used, that is AND, OR and NOT. This is the example 2.4, that is marks obtained by the student in 5 subjects are input through the keyboard. That is, we enter we input 4 marks of the different subjects, that is the 5 subjects, that is through the keyboard. The students get the division as per the following rules, that is they get the division as per the following rules. What is the scenario, or what is the rule that is given? If the percentage is above or equals to 60, that is the percentage that is given is either above or equals to the 60, then there is a first division. And if the percentage is between 50 to 40, 59, that is second, 40 to 49, third, below 40, that is fail. So it is below 40, fail, 40 to 49, third, 50 to 59, second, 60 or above, that is first. Write a program to calculate the division. So this is the question, that is 5 inputs are given, that is the 5 subject marks are given, and on the basis of marks percentage will be calculated. And when the percentage will be calculated, then this is the scenario, that is how division will be divided. That is, if the percentage is greater than 60, first division, less than 40, fail, and then the second and the third division. So these are the third division. So these are the multiple scenarios that is used for the first, second, third and the fail. There are 2 ways in which we can write the program, the same program. These methods are given below. One is method number 1. Remember, these are the comments. Why this is done in the comment? Because this will not compiled by the program. That's why it is written in the comments. Then uses the main function. This is the main function that is used. Then uses 5 marks, that is marks 1, marks 2, marks 3, marks 4, marks 5. That is 5 subject marks will be given. And there is a PER, that is a percentage. Then printf, that is print the command or print the output, that is enter the marks in the 5 subject. That is enter the marks of the 5 subject, that is enter the marks in the 5 subject. Then uses the scanf. Why it is using the scanf? Because these marks must be stored in the memory also, and these all 5 marks and the percentage is also of the integer type. Then it is using the percentage D. So why it is using the percentage D? Because the marks, we enter the marks, we store the marks in memory, and the marks is of integer type. Then use the variables, the M1, M2, M3, M4, M5. Then calculate the percentage, that is adding all the marks and divided by the 5. That is adding all the marks, that is M1, M2, M3, M4, M5, and then sum up all together, then divided by the 5. Now calculate the percentage. If it is greater than 60, that is if the percentage is greater than or equals to 60, this is the if condition that is used, then printf the first division. Else, if the percentage is greater than or equals to 50, then print the second condition. Otherwise, so this is the else part. Within the else there is another if else condition. Else, if the percentage is greater than equals to 40, print the third division, otherwise fail. So 3 conditions are used. One is greater than 40 or equals to 40, greater than 50 and equals to 50, and greater than 60 and equals to 60. This is the one scenario. If it is greater than 60, then no condition, other condition will be checked. Simply printf the first division. But if the percentage is greater than 50, then do not check anything. Simply press or print second division. But if both the conditions are false, then check the condition, next condition, that is greater than 40. Then if it is greater than 40, printf third division, otherwise there is a fail. This says this shows one if, this will be closed. One if, one curly brace, this will be closed, this will be closed, and this curly brace will be opened here only. This is the main curly brace. This is the straightforward program. Observe that the program uses nested if else. As you observe, there is a nested if else. This leads to the three disadvantages. So there are several disadvantages in the nested if else also. What are the disadvantages? As the number of conditions go on increasing, that is, when the number of conditions are increasing, or levels of indentation also go on increasing. That is, when the conditions are increasing, the indentation also go on increasing. As a result, the whole program creeps to the right. That is, the whole program means, and the full program creeps to the right. That is, it creeps to the right part. Next, care needs to be exercised to match the corresponding ifs and the else. That is, care must be given, or care must be exercised to match the corresponding elements, to match the corresponding if condition and the else condition. This is also disadvantage, that we have to check each and every curly brace. Then care must be exercised to match the corresponding pair of braces. All these three problems can be eliminated by the use of logical operator. Now we use the logical operator instead of simple if else condition. What are the three logical operators? One is AND, one is OR, and one is NOT. That can be used by using the logical operator, that is the next method. So now let's start with the next method. The first scenario, first index is same, that is the main function. Then int m1, m2, m3, m4, m5, that is marks obtained by 5 in 5 subject is denoted by m1 to m5. Then there is a PER, that is a percentage. Then uses the printf, that is enter the marks in 5 subject, that is entering the marks in 5 subject. Then scan the values, that is a scanf, that is storing the value in memory by using the percentage %d. Why percentage %d? Because all the marks have a data type that is of integer type. Then calculate the percentage, that is m1, m2, m3, m4, m5 divided by 5. This is till now this is the same, how to calculate the percentage. Now use the logical operator. The first part is the same, there is no else part, only it is used if the percentage is greater than or equals to 60. That is, if it is either 60 or greater than 60, then printf first division, that is prints the value, prints the output as a first division. Next, if the percentage is greater than 50 and less than 60, that is it is between 51 to the 59 or 50 to 59, then print the second division. The question is the same, that it is 50 to 59, so it is equals to 50 and less than 50, that is 50, and then less than 60, that is 59, that is from 50 to 59, then print the value, print the output as a second division. Next condition is that if it is greater than 40 and less than 50, that is from 40 to 49, then there is a third division. So these are the multiple if conditions, these are the statement that was used, that is the use of the logical operators. So if it is greater than 60, first division, 50 to 59, second, 40 to 49, third. If it is less than 40, then printf the fail condition. As can be seen from the second if statement, the ampersand operator is used to combine two statements. So this is ampersand is used, this is the AND is used to combine the two statements or two conditions. Second division can get printed if both the condition evaluates to true. That is, the second condition evaluates or printed or is printed when the condition evaluates to true, that is both the conditions are true. If one of the conditions evaluates to false, then the whole thing is treated as a false. That is, it checks whether both the conditions are true, then only the output is given. Otherwise the output is not given. That is, it checks for both the conditions, that is the left condition as well the right condition. if one of the condition false, then the whole thing is treated as a false. What are the two advantages that can be cited in favor of this program? This says the matching, that is the matching of the if. When we match the if condition with their corresponding else part, that is whenever there is a requirement for matching the if as well as the if, that is there are two if will be used, two else will be used, two if else will be used, two if else will be used. Since there are no else's in the program, that is we can match the if very easily because the else is no, or there is no else. As you see in the program, there is no else part. Next point says, in spite of using several conditions, the program does not creep to the right. That is, instead of using different, or in spite of using different conditions, the program does not creep to the right. It will remain the same. In the previous example, the statement went on creeping to the right. This is the example. This is kept on going to the right. This is going to the right, and gone to the rightmost corner. These effects become more pronounced as the number of conditions goes increasing. This would make the task of matching the if with their corresponding else and number of opening and the closing braces much more difficult. That is, we can check the scenarios, we can check the curly braces, we can check the if. Then next is your else if clause. That is the next part. That is the else if clause. There is one more way in which we can write the program. For example, this involves usage of the if else block as shown in the below. This is the if else. There is a main condition. What is the main condition? There are 5 subjects that can be entered. If it is greater than or equals to 60, then printf. Else percentage is less than or equals to 50, then second division. If less than 40, then third division, or greater than 40, third division, greater than 50, second division, less than 40, fail. So this is the scenario in which there is no curly braces that is used. You can note that this program reduces the indentation of the statement. Why it is reducing the indentation? Because there is no curly braces. We do not remember curly braces and we have to check whether this is open, this is closed. In this case, every else is associated with its previous if. That is, every else is associated with the previous if. The last else goes to work only if the conditions fail. That is, last work or the last else goes to work only and only if the condition fails. Even in else if later, the last else is optional. Now note that the else if clause is nothing different. It is just a way of rearranging the else within the if that follows it. This would be evident if you look at the following code. This is the code that is used if I equals to 2, that is if I equals to 2, that is if the equality check or the equality sign is checked, then printf with u. This is the output, that is printf. That is, if it is equals to the 2, then printf the syntax or printf the statement with the u or with u. Else, if j equals to 2, that is if I equals to 2, print another value. If j equals to 2, print another value. Next condition is if I equals to 2, printf with u. Else if printf this one. So this is the same, but the curly braces are different. We cannot use the curly brace. So this is your choice, whether you use the curly braces at every step or not. Another place where logical operators are useful when you want to write program for complicated logic that ultimately boil down to only 2 answers. That is, there are only 2 answers. This is also used. This is the syntax that is used. Before starting with this example, let's take a break. So let's take 5 to 10 minutes break and then come back starting with this example, that is example number 2.5. So let's take 5 to 10 minutes break. Now let's start with the example number 2.5. So come back from the break, start with the 2.5 example. We have discussed about the if-else and the nested if-else, multiple statement in the if-else, logical operators. This is an example that is based on the if-else whenever there are two conditions. This is another place where logical operators are used whenever there are two answers. For example, consider the following example. This is the example that I will discuss. That is, a company insures its driver. That is, a company ensure its driver if it is married. That the first condition is that the driver is married. The next condition is that driver is unmarried, male, and the above 30 years of age. That is, the driver is unmarried, but it is a male and it is above 30 years of age. Next condition is that driver is unmarried but female and about 25 years of age. So there is a difference between the conditions. One is married, one is unmarried. But if it is unmarried and if it is male, then it is above the 30 years of age, and if it is female, then it is above the 25 years of age. In all other cases, the driver is not insured. So these are the scenarios, these are the cases in which driver is insured, otherwise it is not insured. If the marital status, that is sex, and the age of the drivers are the input, that is the marital status, sex, and the age of the drivers are taken as the input. Write a program to determine whether the driver is to be insured or not. That is, check whether the driver is insured or not based on the condition that is given, that is unmarried, married. So more than one condition is used for the drivers. Here, after checking a complicated set of instructions, the final output of the program would be one of the two. Either the driver should be insured or the driver should not be insured. As mentioned above, since these are only the two outcomes, this problem can be solved using the logical operator. That is, there are only two outcomes, then this statement or this condition, this scenario will be solved using the logical operator. But before we do, let's write a program that does make use of the logical operator. That is, insurance of the driver without using the logical operator. That is, without using any logical operator. First of all, main condition is used, then uses the char. Why it is used with char? Because sex is either male or female. And there is a MS, that is a marital status, that is also either married or unmarried, that is M or U. That is, if it is married or person is married, then the M, otherwise U. Then one variable is taken as a int, that is a age, that is the driver's age. Then uses the printf condition, that is used for printing, that is used enter age, sex, and the marital status. That is either that is enter the age, enter the sex, and enter the marital status, and then scans the values, that is %d, %c, %c. So three specifiers are used. One is %d, that is int age is of int type, that's why it is using %d. Sex is of char type, that's why it is using %c. MS is also of char type, that's why it is using %c. So %d, %c, %c. Yeah, one thing you have to remember, that there is a gap between the specifier. There is a gap between this, there is a gap between this. Then by using the commas, three operators are, or three variables are used, that is %, %sex, and %ms. Then check the condition of the marital status, that is, if the MS is equals to M, that is, if the marital status is M, that is, the driver is married, then printf, the driver is insured. That simply prints the value, prints the outcome, prints the message that the driver is insured. Else means otherwise. If the sex is equals to male, now check the condition on the basis of the sex. So first of all, check the condition on the basis of the MS, that is the marital status. Else, check the condition on the basis of the sex, that if it is equals to M, that is sex is equals to M, that is a male. Then check again the condition, again check one condition. What is the condition? If the age is greater than 30, that if the person or the driver age is greater than 30, then only the driver is insured. So first of all, check whether the driver sex is male, that is whether driver is male. If it is male, then check the age. If it is greater than 30, then only the driver is insured, otherwise driver is not insured. Now check the age of the driver again. If it is greater than 25, driver is ensured. It is on the basis of the sex when the sex is not male. That is, this is the if, this is the if part of the if. Now there is the if else part of the if. This is the this is the else part of the if, not this one. If the age is 25 or greater than 25, that is now checks the age of 25, that if the female, or the check the age of the female, if it is greater than 25, then print or printf driver is ensured. That is, prints the value that the driver is ensured. Then else driver is not ensured. So uses various conditions. First condition is that first of all simply check if the ms is equals to m. That is, if the marital status, if the driver is married, then simply print that the driver is ensured. Else, if the sex is equals to m, that is the driver is of male, that is, the driver is male, not the female, then again check the condition. If it is greater than 20, if it is less than or greater than 20, if it is greater than 30, not 20, 30, then the driver is ensured, otherwise driver is not ensured. Else, that is, else means if the driver is female, that is not male. Else, check the condition. If the age is greater than 25, then printf driver is ensured, otherwise check driver is not ensured. So these are the various curly braces that is used. From the program, it is evident that we are required to match several if and the else's and several pair of braces. In a more real life situation here, there would be more condition to check loading or to the program creeping to the right. Let us now see how to avoid these problems by using logical operator. That is, how to avoid these problems or how to avoid these curly braces by using the logical operator. That is, use the logical operator instead of the multiple if and the else part. As mentioned above, in this example, we expect the answer to be either driver is insured or driver is not insured. If we list down all the cases, this will be driver is married, driver is unmarried, male above 30, unmarried female above 25. Since all these cases leads to the driver being insured, they can be combined together with this one and this one, as shown in the program below. This is the insurance of the driver using the logical operators. Uses the main condition, uses the main function, uses the char variable or the char data type 6 and the ms. Now uses one same again, age, enter the 5 number, that is print the or prints on the screen, as well as take the or store the output or input into the memory. Now this is the syntax, or this is the example how this will be used or how logical operators will be used. That is, if ms equals to 5, that is, if the marital status equals to m, that is, the person is married or person marital status is unmarried, and that is, check both the condition. It is unmarried, then because there is only one condition, it is married, this is the first condition. Then there is a or operator, or, that is, these are the multiple operations, these are the multiple condition, but this is a mandatory condition, and these are the or condition, whether they may exist either one of them, either it is married, either it is unmarried male above 30 or unmarried female above 25. Then uses this one, ms equals to unmarried, that is you, and now check both the condition. If it is unmarried and sex equals to male and age is greater than 30, that is, if it is unmarried, then check the sex. If it is male, then check the age if it is 30. Now these are the three conditions in this line, that all condition must be satisfied in order to give the result, that is driver is ensured. Or, this is the pipe that is used for or. ms equals to u, that is unmarried, and sex equals to f. First of all there is a m, then next is your female, that is your f, and age is greater than 25. So check three condition, one is unmarried, female, and the 25 age or greater than 25. Then only driver is insured, otherwise driver is not insured. This example uses the logical operators. In this there are two logical operators that is used, one is and the or. and three conditions are separated by the OR operators, and within the conditions there are multiple conditions that can be separated by using the AND operator. In this program, it is important to note that the driver will be ensured only and only if one of the condition in parenthesis is to be true. This is one of the condition 1, 2, 3. That's why it is using OR. For the second pair of parentheses to evaluate to true, each condition in the parenthesis separated by the ampersand. As I told you, each section, each operation is to be separated by using the ampersand, double ampersand, that is the AND operation. Next point says, even if one of the condition in the second parenthesis evaluates to false, that is if it is false, then only it also check for the next condition. Then the whole of the second parenthesis evaluates to false. That is, if it is false, then does not check for this one, does not check for this one, because these are the AND operator. If it is false, then do not check all the conditions. The last two of the above arguments apply to third pair of the parenthesis as well. This is also applied to this one. Thus we conclude that ampersand, that is the AND the OR, are useful in the following programming conditions. That is, AND the OR operations are used in the following programming scenarios. What are the scenarios? When it is to be tested whether a value falls within a particular range or not. That is, check whether a particular value or whether a value falls within a particular range or not. Then when after testing several conditions, the outcome is only one of the two answers. This is also a scenario that is either yes or no form. There can more condition situation other than the checking or yes no problem we might use that demonstrate the with the help of example. This is the next example. This you have to study as your own. This I will not tell you because this is the important, and this is the easiest example that uses the logical operators. Now let's start with the next operator, that is a NOT operator. Till now we have covered AND the OR. Now there is a NOT operator. This operator, this says that it is a NOT operator that is denoted by the exclamation mark. This operator reverses the result of the expression. Reverses the result means that is, if it is true, it becomes the false. If it is false, it becomes the true. So this reverses the result of the expression it operates on. For example, if an expression evaluates to a non-zero value, then applying exclamation operator to it results into a 0. That is, gives the output results into a 0, and vice versa. If the evaluation results to 0, then when apply the exclamation operator, it makes the 1, that is a non-zero value. So if it is 0, it makes 1. If it is 1, it makes 0. The final result, that is after applying exclamation mark 0 or 1, is considered as the false or true respectively. Here is the example of the NOT operator that is applied to a relational expression. Wow! This is a relational expression, that is we use the relational algebra, that is less than, greater than, more than, or less than equals to, greater than equals to. This means not y less than 10. In other words, y is less than 10. The expression will be false since y is less than 10 is true. We can express the same condition as the y is greater than equals to 10. The NOT operator is often used to reverse the logical value of the single variable as shown below as in the given expression. If it is not flag, this is another way of saying if flag is equals to 0. This is not flag, this is if flag is equals to 0. Does the NOT operator sound confusing? Avoid if you want. The same thing can be used without using the NOT operator. Now, what is the hierarchy of operators? That is, what are the hierarchy of the logical operators? Since we have now added the logical operators to the list of operators, till now we have discussed only arithmetic operator. Now, next operator will also be added, that is the logical operators. Now, what is the hierarchy, or what is the hierarchy in which operator will be performed. First of all, we studied multiplication, division. Now logical operators is also added. So what is the hierarchy right now? First of all, there is a logical node. This is a logical node. Then that is, first of all, there is a NOT operation that will be performed. Then uses the arithmetic and the modulus operator, that is multiplication, division and the modulus, that is the ratio sign. Then uses the plus and the minus, same addition and the subtraction. Then there is a relational operators, that is less than, greater than, less than, equals to, greater than, equals to. Then again next hierarchy contains the comparison operator and the not equals to operator. This is also a relational operator. Then at the next place there is a logical and, then logical or, then assignment operators. These are the operators and their syntax and their types and their hierarchy that can be maintained in the C language. A word of caution: what is the output of the following program? The main function is used, int I, that is one variable is declared that is of integer type. So one variable that is takes only discrete values and the specifier is %d. So it takes the input, or this program takes the input from the user, that is printf, enter the value of I, that is enter the value of I, then store in the memory, that is %d %I. Now checks the condition. If I equals to 5, that is if I equals to 5, then printf you entered 5. This is wrong because the comparison operator is done by the double equals to. So here it is double equals to, not single equals to. So this is wrong. If I equals to 5, that is if I is equals to 5, then only printf you entered 5, else printf you entered something other than the 5. Then curly braces close. Here is the output of 2 runs. Enter the number of I. If I entered 200, that is 5. If I entered 999, that is 5. No, this is not wrong. This is for your confusion purpose. That is everyone understand that it is used for the condition if, then it must be of I is equals to 5. No, this is not a comparison operator. This is only a assignment operator. So this 5 will be assigned to I. Then it must be any input that is given by the user. The output is always 5. Why output is always 5? Because we can, or we have assigned the value, not compares the value. Yeah, this is most important point. Surprisingly, you enter 200,999 and still you find the same output, that is 5. This is because we have written the condition wrongly. This is the wrong condition. We have used the assignment operator equals to instead of the relational operator, that is a comparison operator. As a result, the condition get reduced to the if 5. Wow. That is, it will reduce to the if 5. That is, only the 5 value will be stored, irrespective of what you supply as the I of or the value of I. And remember the C truth, it is always non-zero, where falsity is always 0. Therefore or thereafter, if 5 always evaluates to true and hence the result. Another common mistake while using the if statement is to write a semicolon after the condition. This is not a another common mistake that is used, then uses the semicolon in at the end of the condition. That is also wrong. Why? Because the condition is checked and we cannot use the semicolon after the condition. This is the wrong. Why it is wrong? Because it is using the semicolon after the condition. This is the condition and semicolon will be used after the condition. The semicolon makes the compiler to interpret the statement as if you have written in the following manner. If it is equals to 5, then printf you entered the 5. Here if the condition evaluates to true, then the semicolon gets executed, following which printf gets executed. If the condition fails, then the straight away the printf gets executed. Thus, irrespective of whether the condition evaluates to true or false, the printf is bound to be executed. That's why this is the error why we are not using the semicolon after the condition, because that makes the foundation on the printf to print the output. The following figure summarizes the working of three logical operators. This is the operator that can be used. One is AND, one is OR, one is NOT. These are the values x0, y0. First of all, find the x0. 1, in the same way 0, again 1, then non-zero. For the non-zero there is a output that is a 0. So whenever we use the non-zero value, then the output is 0. That is a reverse because it is using the NOT operator. Then next again non-zero, then again only 0. Then y. This is the y, this is the y, and this is the not y. Whenever it is 0, it is 1. It is non-zero, it is 0. It is 0, it is 1. It is non-zero, 0. Then uses x and the y. That is uses or combine these two values. That is performing the AND operation. AND operation means if both the conditions are true, then only the output is true. That is 0, 0. That is both the output are 0. Then the both the inputs are 0. Then output is also 0. In this, 1 is 0, 1 is non-zero. Output is 0. Why it is 0? Because both the conditions are false. Then non-zero, 0. Then again 0. Here, both the conditions are non-zero. That is, both the conditions have some value. That is 1. That is, both the conditions are true. Because 1 is represented by true and 0 is represented by false. So both the conditions are false, then both the conditions are true. That is, both the conditions are true means both the inputs are the 1. Then the output is also 1. That is a true. Then uses x or y. Now here there is a 0, there is a 0. Both the inputs are correct or one of the input is correct? No, because both inputs are false. Why false? Because it is 0. Then the output is also false, 0. In this there is a 1. This is a 1, non-zero, there is a 0. That is, two conditions are used. One is non-zero and one is 0. That is 1 and the 0. In this, one of the condition is true. That is, 1 is 1. Or the one of the input is 1. So the output is 0. Why? Because 1 is non-zero, 1 is 0. Then non-zero, 0. This is 1, not 0. This is 1. In the same way, non-zero, 0. This is also 1, non-zero, non-zero. That is also 1. So in simple terms, in our AND condition, in AND operator, we check both the condition. If both the conditions are true, that is not 0, that is 1, then only the output is 1, that is non-zero. Otherwise, the output is 0. And in the OR condition, if one of the input is true, then the output is true. Next is your conditional operator. This is your next operator that will be used. The conditional operator, that is denoted by the question mark and the colon. That is the two dots, that is the colon and the question mark. This is the conditional operator, that is question mark and colon are sometimes called ternary operators. These are the two operators that are known as the ternary operator, that is T-E-R-N-A-R-Y. Since they take three arguments, in fact they form a kind of four sorted or four sorted if then else. That is, they form a four sorted if then else condition. Their general form is expression 1 question mark, expression 2 colon, expression 3. That is, if the condition is true, this is the condition. If the condition is true, then performs the first statement, that is expression 2, otherwise performs the second statement, that is expression 3. So uses two condition. first of all uses question mark, that is only used for the condition, then uses two statements that are terminated by or that are separated by colon. So two operators are used, and both the operators are known as the ternary operator, that is the question mark and the colon. So this is expression 2 and expression 3. What this expression says, if the expression 1 is true, that is if the condition is true, that is if its value is non-zero, then the value returned will be expression 2. That is if this statement is true or if this condition is true, then only this statement will execute, otherwise the value returned will be expression 3. This statement will return. Now let us understand with the help of few examples. There are two variables that will be declared of int type, that is int x comma y. Scan the value, that is store the value in the memory, that is ampersand x. Then uses the y. Y is another variable that stores the output of the conditional operator. That stores the output of the conditional operator that is given by the conditional operator. That is given by the question mark and the colon. So this stores the value, that is x is greater than 5. So this is the condition that if x is greater than 5, then means this is the output, that is question mark 3, otherwise 4. So if it is greater than 5, then prints the value as a 3, otherwise prints the value as a 4. The statement will store 3 in the y if x is greater than 5, not equals to 5, it is greater than 5, that is 6, 7 and so on. Otherwise it stores the output 4 in the y. So if it is greater than 5, x is greater than 5, then only the output is 3, otherwise the output is 4. The equivalent if statement will be, that is equal to the conditional operator, there is a if statement. That will be if x is greater than 5, then y equals to 3, else y equals to 4. Then next statement, next example, taking the char a, that is taking the character variable, that is a, that stores only one variable or one text at a time. Then uses int y, that is uses the variable that is of integer type, that is a y that takes only 2 bytes, that is takes only discrete values. Then scans the value, that is stores the value in the memory, that is ampersand a. Then checks the condition, store the output in the y. That's why it is using y equals to. What is the condition? Two operators are used. Two functions, two instructions are used, and both the statements are combined with the help of the AND operator. That is, if it is true and it is true. If both the conditions are true, then the output is 1, otherwise the output is 0. Here 1 would be assigned to y if a is greater than or equals to 65 and a is less than or equals to 90. That is, if it is 65 to 90, including both 65 and the 90, that only the output is 1, otherwise the output is 0. That is, if the character that is given by the user, it lies between the 65 to the 90, that is including 65, that is the ASCII value of a, as well as the 90. So if it is lie between the 65 and 90, then only gives the output as a 1, otherwise gives the output as a 0. The following points may be noted down about the conditional operators. It is not necessary that the conditional operator should be used only in an arithmetic expressions. It is also used within the printed statements also. This is the example. First of all, take the int I, then take scanf, then store the output in the memory, store the input in the memory, then checks the condition. What is the condition? If I, that is a variable that is given by the user, is equals to 1, that is if it is equals to 1, that is I value is 1, then means question mark, then printf, the output is Amit, otherwise printf all and sundry. So this is the conditional operator that is used, that if the I value is 1, then print the Amit, otherwise print all and sundry. Next example is char a equals to z, that is store the z value into the a, ascii value of z into the a. Now printf, it is also conditional operator is also used in the printf, also uses the printf, that is percentage c comma a is less greater than equals to a. So check the condition. If it is greater than equals to a, then gives the output as a, otherwise gives the output as a not operator, that is a exclamation operator. This means conditional operator is also used within the if or within the if or printf within the if. Next point says the conditional operator can also be nested, that is we can nest the conditional operator. This is a conditional operator, we can also use the conditional operator, that is conditional operator within the conditional operator. So that's all for this chapter. Yeah, this is the important paragraph. The limitation of the conditional operator is that after the question mark or after the colon only one C statement can occur. So this is a very big limitation, that after the question mark only one statement will be executed or one statement can occur, and also when we use a colon for the printing purpose, then only the single statement will be stored or will be put, or we can store single statement after the question mark after the colon. In practice, rarely is this the requirement. Therefore, in serious C programming, conditional operator are not frequently used as the if-else. That is, the conditional operator is not used in a frequent for the huge number of or the large codes. Why? The main reason is that there are some limitations, that is only one statement is used after and before the question mark as well as the colon. So this is not a good code, this is not a good operator that is used. So the high level programmer do not use the C conditional operator, instead they use the if-else statement. Now what is the summary of this chapter? So let's finish with this chapter by using the summary. That is, there are three ways for taking the decision. What are the three ways? If, if-else, nested if-else. That is, first way is to use the if-else statement, the second way is to use the conditional operator, third way is to use the switch statement. So there are three ways that can be used. One is if-else, one is switch, one is the conditional operators. The default scope of the if statement is only the next statement. So in order to execute more than one statement, they must be written in a pair of braces. An if block needs not always be associated with an else block. Hence, however, else block is always associated with the if block. So these are the summary. Next point says, if the outcome of the if-else ladder is only one of the two answers, then the ladder should be replaced either with an if-else clause or by logical operators. Next point says, these are the binary operators, whereas this is a unary operator. In C, every text expression is evaluated in terms of zeros and non-zeros values. A zero value is represented as false and the non-zero is considered as a true. Assignment operators are used with the conditional operator that must be enclosed within a braces. This is the exercise that you have to perform by your own. For example, let's take this example. In this, two variables are used. One is x, one is y. X stores 10, y stores y. Now check the condition. If x is equals to y, that is if 10 is equals to 20, then prints the value of x and the y. But this is not the correct condition, then it does not gives any output. These are the examples. There are so many examples for your purpose, for your practice purpose. This is a practice problem for the logical operators. This is also the practice problem for the logical operator. This is pick out the error. What is the error in the program? Now pick up the error. This is the code, for example. First of all, store the value of x into or 10 into x, 20 into y. Then uses if x is greater than equals to 2 and y is less than equals to 5. That is, it is between 2 and the 50. That is including the 2, including the 50. Then print the value of x. These are the various programs in the C language. Then these are the questions on the basis of the conditional operators. These are the programs for the conditional operators. Now next chapter is your looping, that is the loop. That is the next chapter that I will discuss in the next class. So let's stop over here only. In the next class I will discuss with you the looping part, that is a loop. What is a loop? What are the types of loop that is available? So that's all for today's session. Now if you have any doubts, then please text the doubt and I will answer you. In the tomorrow's class I will be starting with your loops. So that's all. Thank you so much everyone.